So my name is Jess. I'm XJM on Drupal.org, and I'm part of a team of about a dozen Drupal 8 core committers who review and commit everyone's core patches. Within that team, I'm one of the two release managers. The two of us are responsible for actually tagging the releases that you can install on your sites each month, as well as setting schedules, evaluating the potential disruption of changes, managing scope, and so on. I've helped coordinate basically all of the minor and security releases that we've had for Drupal 8 to date, and I've personally tagged the majority of the security releases myself. So when your Drupal 8 site says security update required, or actually your Drupal 7 site now too, you can probably think of that as me saying, hi, that's me. So the title of my talk is Security Drupal 9 and Navigating the Changing Web Landscape. The web is a very different place than it was back in 2011 when Drupal 7 was released. And I'm not actually talking about headless setups or machine learning or multi-channel or even object-oriented PHP. I mean a fundamental shift in the way that web software is packaged, developed, and released. These shifts affect how we developed Drupal 8, how we're developing Drupal 9, and how Drupal will be developed going forward. Most importantly, they affect what we have to do to keep Drupal sites secure, now and in the future. Here are examples of some of the kinds of shifts that I'm talking about. The launch of GitHub in 2008. The adoption of modern package managers like Composer, NPM, and Yarn. Standard specifications like PSR 0 and ES6. The release of PHP 7 and GDPR. So first, let's take a look at what we changed in Drupal 8. One of the most important changes we made in Drupal 8 is that we actually schedule our releases now. Amazing, right? We follow semantic versioning to add new features without breaking backwards compatibility. See, back in the day, Drupal was ready when it was ready, with no new features available until an entire major release was ready to ship. Starting with Drupal 8, though, releases are scheduled and announced in advance. And one of my responsibilities as a release manager is setting the schedule and managing changes toward those release dates, making sure that nothing puts a release date at risk. So each minor release receives 6 months of bug fix support, followed by 6 months of security coverage. Another important change with Drupal 8 is that we adopted modern best practices in tooling. Overall, there's a lot more third-party code in and around Drupal 8 compared to previous Drupal versions. You've probably heard that Drupal 8 depends on Symfony and Twig, for example. We manage and package Drupal 8's PHP dependencies with Composer, which is basically the industry standard at this point. That's this icon, in case you were wondering. This is not a pop quiz, but it would probably make a great Drupal trivia next slide. Also, during the Drupal 8 development cycle, we refactored or rewrote basically everything in Drupal core. There's code maybe in the batch API or file.inc that hasn't changed in more than a decade, and the hook system's still there. But other than that, Drupal 8 APIs are pretty drastically different than any previous Drupal versions. We also released Drupal 8.0 before the data migration path from Drupal 7 was, because we wanted to give new sites an opportunity to build on the new functionality in Drupal 8 while we were finishing that migration path. So even though there are a lot of improvements in Drupal 8, it's been a slow process getting sites from Drupal 7 to update. So with that in mind, let's take a look at what we're changing in Drupal 9. And the answer is not much. We want to keep innovating, but we don't want another difficult upgrade. So following the release of Drupal 8.0, we've adopted the continuous upgrade path, which is a concept we got from Symfony. When we want to improve something now, instead of rewriting things wholesale, we add the new code in minor releases while leaving the old code in place. And the old code is just marked deprecated with a link to the replacement. This means that essentially we're developing Drupal 9 in Drupal 8. It also means that developers don't have to wait around until Drupal 9 is stable to make the modules compatible with it. All they have to do is move away from deprecated code whenever it works for them. We're targeting the release date of Drupal 9 for June of 2020, with a fallback date in December 2020. And Drupal 9.0 will be exactly the same as the last minor release of Drupal 8, except for two things. The dependencies that we've accumulated since 8.0 will be removed, and the deprecations that we've accumulated since 8.0 will be removed, and then the dependencies will be updated to new major versions. Updating from Drupal 8.9 to 9.0 shouldn't be much more difficult than upgrading between minor releases, so long as you keep up with deprecations. Now, those of you running Drupal 7 might be a little worried by that preferred release date a year from now, because historically, support has ended for an old version of Drupal when the major version 2 after it is released. However, the reality of the situation is that about 2/3 of Drupal sites are still running Drupal 7, partly because of the difficult upgrade path, and partly just because Drupal experienced its steepest growth during Drupal 7's active support. So it's going to take a long time to get all these sites updated. We took this into account and decided we needed to support Drupal 7 much longer after Drupal 9's release. So we supported it until November of 2021. That means you have about 2.5 years to prepare your site for Drupal 9. And even if you're on Drupal 7 now, the best thing you can do to preserve your site is still to update it to a later release, the latest release of Drupal 8, and not to use deprecated code. The deprecation process and continuous upgrade path mean that Drupal 7 to 8 will be your last difficult upgrade. Since Drupal 9 is basically just a continuation of the Drupal 8 series, Drupal 8's end of life is actually the same date, November 2021. That's when Symfony 3, the major version of Symfony currently used by Drupal core, reaches its end of life. So let's talk for a moment about what the release schedule actually looks like for the next few years. We have ongoing security coverage for Drupal 7. Then in December of next year, we're releasing Drupal 8.8, which will be the last normal feature release of Drupal 8. After that, we'll be pairing Drupal 8.9 with Drupal 8 LTS and 9.0 together at the same time. And the Drupal 8 LTS will have both security support and full bug fix support until its end of life in 2021. After that, after both Drupal 7 and 8 are end of life, we'll be supporting only Drupal 9, starting in November 2021 and for a short period of time thereafter. So I promised you we schedule our releases now, and that releases are predictable. But the support calendar in my last slide, it conveniently ends in the middle of 2022, in the middle of Drupal 9's active support. So fast forward to November 2021. Drupal 7 will have received 11 years of support. Drupal 8 will have had 6 years. The end of life for Drupal 7 is a pragmatic decision we're making based on trends in the ecosystem. But the end of life for Symfony 8 is directly in response to the end of life for Symfony 3. And that's going to become the new normal, with our dependencies influencing our major release schedule. So when is Drupal 10 going to be released, and when is Drupal 9 going to be end of life? It's a complicated puzzle to solve, and it depends on our dependencies. So now we're going to take a closer look at Drupal's dependencies, package management, and dependency security, and think about how these things affect both your sites or applications in Drupal's future. At the end of the day, the reason we have dependencies is to save work. We reduce the amount of code we have to maintain ourselves with the goal of increasing the overall code quality and sustainability of Drupal as a project. People use Drupal to build powerful websites with robust data modeling. That's what we're good at. So why should we also write and maintain software to interpret HTTP requests or run automated tests? Other open source projects have done those things better, so let's use them. That said, using third-party dependencies also adds new challenges to maintain Drupal and to keep it secure. To explore the question of how Drupal's dependency security affect Drupal's own security, I'll first give some very quick background information on Drupal's own security practices. Drupal practices coordinated disclosure, which is defined as a security model in which a vulnerability is patched. A vulnerability is published only after a period of time that allows for the vulnerability to be patched. The goal of coordinated disclosure is to prepare fixes and allow sites a chance to update before giving potential attackers information that could be used to exploit the vulnerability. And the Drupal project has been following this model for more than a decade. To facilitate coordinated disclosure, Drupal security issues are reported in a private issue tracker that only the Drupal security team has access to. We release each fix with a security advisory during predefined security release windows on Wednesdays. For core, no other fixes are included in a security release beyond what's needed to fix the vulnerability, and we try to make the security fixes themselves as non-disruptive as possible. The goal of all of this is to allow site owners to apply their security updates immediately, at a predictable time, without worrying that their sites are going to break. An important part of coordinated disclosure is coordinating with other projects, so that one project isn't disclosing vulnerability in another before there's fixes available for both. So we coordinate security releases with our upstream dependencies when it's possible. For example, when there's a security issue that affects both Drupal and Symfony, we release our fix the same day they do. This can also mean working with other projects that share our dependencies. Last month, we had a release with Typo 3 and Joomla because there was a vulnerability reported to the Drupal security team for a library that all three projects share. So coordination with other open source projects has actually become a significant part of the work the security team does for Drupal 8. Among all of the Drupal 8 core security releases we've had to date, 1 in 3 have involved upstream vulnerabilities. Now, this doesn't mean our dependencies are any less secure than core. Theoretically, all things being equal, if we were the ones maintaining the code, we'd have the same number of vulnerabilities. But it does impact how we schedule and ship releases. When we have a vulnerability in our own code, we can review the test and test the fix ourselves in advance of disclosure. We can plan ahead, we can set the schedule. We can bundle multiple security fixes together in a single release so that site owners don't have to apply so many updates. When making a release for an upstream dependency, though, all that goes out the window. Hopefully, we'll find out in advance that a security release is happening for one of our dependencies, but sometimes we don't. Sometimes we work with the upstream project to set a coordinated disclosure date that works well for us, ideally on one of our security windows, but it depends on the project, and that's not always possible. Sometimes, not always, we get patches ahead of time that we can attest against our code base in private. But testing a private, unreleased patch against a composer dependency it's difficult and frustrating, I just said that. We also can't stage the core releases in advance. We have to wait for upstream to issue their release, then retest it, tag it, package it, publish it, all the day up. And finally, an upstream fix is more overhead both for us and for sites, because we have to make more releases for fewer vulnerabilities, rather than bundling multiple vulnerabilities on release dates that work for us. Another challenge we face with security vulnerabilities in our dependencies is how to ensure that Drupal sites are secure when our dependencies release cycles don't match up. To illustrate this, I have an example of a dependency security issue from last August. To understand the whole picture, let's backtrack to Drupal 8.0's release in November of 2015. When released, it supported PHP 5.5 and 5.6. We also essentially supported PHP 7, even though PHP 7 wouldn't be released for another 2 weeks after that. Now, 8 months later, in July of 2016, PHP ended their official security coverage for PHP 5.5. However, even at the start of 2017, 6 months after that, nearly 20% of PHP websites were still using PHP 5. Now keep in mind, some Linux distributions provide their own security patches for PHP versions used by their long-term support releases. And PHP 5.5 was used by Ubuntu 14.04, which actually had security coverage from Ubuntu until just this past April 2019. So you can see how a site owner on that stack might reasonably expect their PHP 5 applications to be working. Updating PHP versions is also a time-consuming task for some organizations, especially in places like higher education, where there might be many applications built in-house running on the same servers. So to try to reduce disruption to the ecosystem, we made a decision to drop support for PHP 5.5 and 5.6 at the same time, and to announce it at least a year in advance so that organizations had a time to update their hosts and applications to PHP 7. So we announced in January of 2018 that Drupal would require PHP 7 starting in the spring of 2019. There was a risk in supporting PHP 5.5 for so long because it meant we had an increasing number of sites of dependencies on old versions that weren't compatible with 5.5. But we were weighing that against the risk of denying 15 to 20% of Drupal sites any security updates at all. Because that's what happens when we increase the PHP version requirement. Sites that are on an older PHP version can no longer install Drupal security updates. Then in the summer of 2018, we received a report of a URL rewriting cache poisoning vulnerability. The researcher who reported the vulnerability also informed us that he'd be disclosing the exploit in August, so we had to come up with a fix before then for coordinated disclosure. My colleague Wim researched the report and found that the vulnerable code was present in both Symfony and a couple of Zend libraries, and that's where Drupal was getting it from. So we collaborated with the security teams of all three projects, as well as the researcher, to find a coordinated disclosure date that worked for everyone, and came up with August 1st. But then there was a problem. Very late in the process, I discovered that Zend had dropped support for PHP 5.5 from those libraries in a couple of minor releases in mid-2017, while 15% of sites were still using PHP 5. And also, additionally, that Zend didn't provide any security coverage for those old versions. So we couldn't update Drupal to require the secure versions from the release that we helped coordinate, because we didn't meet their PHP version requirements for it. Now, fortunately, it turned out that Drupal itself was only vulnerable because of Symfony, and we weren't exercising the vulnerable code in Zend at all. But we put a note in the advisory that anyone using the Zend libraries directly should update them, and then just updated Symfony in our own release. It was a near miss. What if Drupal had actually been using the vulnerable code in Zend, right? We couldn't just drop support for PHP 5.5 during the security window that would cause chaos and mass panic. Can you imagine being that site owner? Would we have tried at the last minute to convince project maintainers to make a release contrary to their release policies? Would we have forked or overridden the library's vulnerable code and then scrambled to backport the patches to an unsupported version of their software? And then what if backporting the patch across so many major versions was difficult? What if it took days or weeks? We wouldn't have made the window. And then if we did fork the code, how disruptive might that be to Drupal sites and modules that we're using in the future? So all this shows how important it is to keep dependencies up to on the latest versions, but also the complications that we have for doing so. It's not only Drupal 8 security that's being affected by our shift to extra dependencies. If you apply Drupal updates regularly, you might have noticed that there have been a lot of core releases recently. In fact, there have been 34 total core releases tagged so far in 2019, which is far and away a new record. For comparison, under all the same release policies, there were only 33 releases in the entirety of 2018. So it's not just your imagination. There really have been twice as many releases as normal this year. And, coincidentally or not, half of those releases have been needed because of a dependency, one way or another. So let's take a look at the specific composer dependencies Drupal 8 has, what they're for, why they're there, and what managing them with Composer means. I have some illustrations my colleague and fellow security team member Cash shared back at DrupalCon Seattle. This shows Drupal 8's composer dependencies as of Drupal 8.0. The biggest segment here is the purple. That's Symfony, like I said, our most important dependency. Then the green is Guzzle, an HTTP client, which we used to replace a single Drupal 7 function that had an endpath complexity of over 25 billion. So arguably a good choice to add Guzzle for our maintainability. The yellow is a small library for validating email addresses. The orange here is Doctrine, which is our annotation parser for plugins and such. Gray is us, Drupal core. And then the pink is the Zend stuff I was talking about, things for parsing RSS feeds and whatnot, plus Diactros, which we use for PSR7, even though Guzzle also provides its own PSR7 implementation, don't get me started. And then squeezed between that, Diactros and Symfony, is the Wikipedia merge plugin, and I don't know why it's so small on the sandwich. Twig is right here, which is the new theme templating layer we have in Drupal 8. Now fast forward to Drupal 8.7, which was just released, and we have a maybe 30 to 50% increase in the number of dependencies in core. The new salmon-covered stuff here is stacked cores, which is a cross-origin resource sharing library useful for headless setups. The typo3 parse var string wrapper here is a dependency we added back just this January to mitigate a remote code execution vulnerability that exists with native PHP var functionality. And finally, the blue stuff here being new is actually kind of misleading. Archive tar is a dependency we've had since Drupal 7, and it's just that previously it was in a weird, stale, almost not quite forked state. So we just made things easier in 8.7 by making an actual composer dependency. Now, of course, your typical Drupal site runs a lot more than just core. You can do a lot with core out of the box these days, far more than you could with Drupal 7 or 6 or 5. But still, a lot of what makes Drupal powerful is its extensibility and its contribute ecosystem. Every module is another dependency for the site, and it brings its own dependencies with it. So even a simple distribution can add a lot. This is the diagram for Lightning, which I don't feel bad showing you because it's an Acquia product and I know it's generally well maintained. Lightning is a starter kit for a generic Drupal site, very basic, with some Acquia integration baked in. But even this starter kit is already quite the tangle of over 100 dependencies, even without any advanced features like commerce or anything. And when you start building a site on top of this, with additional modules and packages, it's easy to get to many of hundreds of dependencies. Few organizations can audit that much manually. So that brings me to the drawbacks of using Composer. Some of these are general problems with any package manager. Others are specific to Composer itself or to Drupal's implementation of it. The point of the package manager is to not have to worry about upstream dependencies or version conflicts. When you install a package, the package manager will helpfully pull in its dependencies, and its dependencies, and its dependencies, and so on. So you don't necessarily know what you're installing in your application or who owns it. This can cause some of the release management challenges I've already described, where there's difficulty balancing stability and security among many different libraries. But it also makes it that much easier for something you didn't want in the first place to break your site, or even to trick you into installing malicious code. Information about composer dependencies also isn't surfaced anywhere in the Drupal user interface, the way that module information is. A related problem is that there's a disconnect between the security services Drupal provides and the security of the composer packages that feature within modules or individual sites install. So something you might not have thought about is that Drupal.org is a package registry with robust security features, I'd say actually. Rich metadata about releases, built security reporting, push notifications, and coordinated disclosure across thousands of projects maintained by a dedicated volunteer security team. For core, we update our composer dependencies when they have a security vulnerability if core itself exercises the vulnerability. But that doesn't help with vulnerabilities exercised by your own code or by other packages you or other modules have installed. The policy is that you're responsible for keeping third-party dependencies you installed yourself up to date. But that's problematic too, because Composer also lacks any form of built-in security auditing or monitoring. In fact, it lacks any concept of security advisories whatsoever, and furthermore, the Composer maintainers are pretty set against adding support for it. There are some third-party tools and libraries that try to fill this gap by tracking CVEs or declaring dependency conflicts with insecure releases of projects. But it's all opt-in, not always up to date, and really no substitute for native functionality. A somewhat related issue also is that the vast majority of Composer packages are maintained on GitHub, which has no mechanism for private issue reporting, which makes coordinated disclosure a problem. Although just this past month, GitHub did introduce security policy and advisory features, so I would hope that maybe in the long term this is going to influence the Composer ecosystem and open source in general. Fingers crossed. A final thing that I learned from Cash at DrupalCon Seattle is that composer.json can specify arbitrary shell commands and run them on install, which makes a case for auditing composer.json of every package you install and running composer install in the VM when doing development. Because otherwise you're essentially giving it your command line access. So those of you in the room who are JavaScript developers might think that it's adorable that I've just spent several slides bemoaning the perils of having a few dozen composer dependencies. The modern JavaScript ecosystem is different in ways that terrify me, and not just because my JavaScript coding skills peaked in about 2003, although I will admit that it's also a factor. So before we talk about the future of JavaScript and Drupal, let's talk about the past and present. These are Drupal 8's current JavaScript dependencies. Now, I can't show you any fancy illustrations of this because we don't use a package manager for them. They're just all committed to core in an assets vendor directory. 13 years ago, jQuery was added to Drupal 5. Yay! And later that year, Fantastic was added to allow the Garland theme's colors to be customized. Who remembers the Garland theme? Yay! Garland! It was so shiny at the time. Then 10 years ago, jQuery UI was added to Drupal 7 to support accessible modal dialogues. All three of those are still part of Drupal 8 core today. But the rest of these, everything else on the slide, like Backbone, CK Editor, Match Media, and so on, are all new in Drupal 8. Now, 24 total packages doesn't seem so bad when compared to those composer dependencies, right? The trick here is that without a package manager or proper test coverage, updating these libraries is both tedious and risky. And frankly, a lot of the JavaScript in these libraries is pretty legacy, which also adds to the maintenance burden. So let's take a closer look at our recent history with jQuery and jQuery UI, which are probably the most tightly coupled JavaScript dependencies we have. We'd really hoped to upgrade to jQuery 3 before the release of Drupal 8.0.0, but unfortunately jQuery 3 was still in alpha at the time of its release. In fact, a stable version of jQuery 3 wasn't released until mid-2016, the next year. And there were publicly disclosed security issues that jQuery said they would not fix by 2017, even though they'd said at the time of 3.0's release that they would continue to provide security coverage for jQuery 1 and 2. While Contrib itself wasn't vulnerable to any of these issues, while core wasn't, there was at least one contributed module that was, and there was also some problematic documentation on Drupal.org that made it seem likely there was vulnerable custom code out there as well. So we were at least concerned with the possibility of other vulnerabilities in the future. Public disclosure, no support for jQuery, exploits in the wild, sites hacked before we could update them, and all that. So given all that, we decided we needed to do a major version upgrade for jQuery 3 as soon as possible. Overall, because of compatibility issues with both jQuery and jQuery UI, it took more than 2 years from when we first started tracking jQuery 3 at the time of its alpha release in 2015 until we were able to make it core compatible with it in 2017. And then even once complete, this update did have downsides. Those same compatibility issues that core had to resolve were just as likely to affect contrib and custom code. So this was one of a couple of things that made Drupal 8.4 a disruptive minor release, actually breaking people's stuff and disincentivizing them from updating to a secure release of Drupal. Weighing that against the very real risk of sites being hacked before we could update was a tough call. Ideally, we'd only do major version updates in new major releases of Drupal, but other projects' release schedules don't always make that possible. Overall, if we do need to break sites, we'd rather do it in a regularly scheduled minor release when sites can plan ahead for some disruption and test thoroughly before deploying. Because if we break sites in security release, people can't plan ahead for that, and it'll make it so people can't install their security updates immediately the way that we want them to. Since that time-consuming jQuery and jQuery UI update, jQuery UI hasn't seen any further development at all. In December of 2017, there was a blog post suggesting that the jQuery UI maintainer had stepped down and that the project would be merged with jQuery Mobile. However, jQuery Mobile doesn't support jQuery 3 yet, and has no stable release since 2014. And it's also unclear whether the new version that's under development will even be a complete replacement for jQuery UI. Then there's jQuery itself. We know from the previous example they're not terribly consistent with their security coverage. And they also tend to discuss security issues in public and fix them in disruptive releases like minors or even majors. And 2 months ago in April, it was announced that jQuery 3.4 would be the last minor release of jQuery 3, and that jQuery 4 was under development. If jQuery 4 is released sometime in the next couple of years, this puts us maybe in a tricky spot. Because jQuery 3, as we know, isn't guaranteed to have security coverage after jQuery 4 is released. We know jQuery UI isn't going to be made compatible with jQuery 4, and it's certainly doubtful jQuery Mobile will be either. So what do we do? What do we replace it with? We need to audit how it's used to figure out what to do in each case. And the issue on the slide is because we're discussing this, issue 3051352. If you want to help with it, sprint in this room after this talk, especially if you're comfortable with legacy jQuery UI code and Drupal's implementation and text thereof. We'd love your help with that. So now let's talk about what Drupal's JavaScript might look like in the future. In January of 2016, Dries announced that Drupal would adopt a modern JavaScript framework, and the framework our JavaScript contributors picked was React. Now, one of the advantages of React is that it's well-maintained with a mature release process. And we can be fairly confident it will continue to be well-maintained because it's used and backed by Facebook, which you might have feelings about. It's in both the plus and the minus column on purpose. But at a minimum, it gives us some future-proofing. React also has a strict backwards compatibility policy and a deprecation process similar to our own. However, the major releases are quite frequent, much more frequent than Drupal's, breaking changes every 18 months or so. It's also surprisingly difficult to find any information about React security policies. I looked for a long time. Presumably, Facebook has incentive to keep both React itself and its upstream dependencies safe, but I couldn't find any information at all about how to report a security vulnerability or how security is managed. The only thing I could find was a single CVE from last year for React on server. Based on the releases they made then, it looks like they provide security coverage for all minor releases of the current major version, but that the previous major version receives no security coverage. This also might mean that there's only short windows of security coverage for packages upstream and downstream of it, because it's the thing that sort of leads the way for the ecosystem. Now, this isn't something that I know a lot about, so if you're a React developer and you know more about this, I would love to hear how it works after the session. Anything you can tell me about React security policy. What I see as the biggest challenge we'll be facing with React is actually more a fundamental thing about the NPM ecosystem itself. There's a tendency for NPM developers to create very small libraries and then open source them independently, which in some ways is great. Instead of installing a monolithic thing, you just pull in one teeny tiny piece that you need. And it's also cool that there's a thriving community of open source code being exchanged. Sometimes these packages can be as small as a single function. Keep in mind, JavaScript doesn't have a standard library. It's basically the exact opposite of PHP, where there's a unique function for every possible thing. What's most important for JavaScript is the spec, so different browsers and clients can work together and have their own implementations. That means the language doesn't carry around a lot of bloat in terms of utility functions, which in turn means JavaScript developers need to code up equivalents themselves, or pull them in from someone else's open source package. Which brings me to the infamous left pad. A lot of people probably knew I was going there. So those that don't know the story, leftpad is a little NPM package that adds padding to the left side of the string. Not the right side, just the left side. Back in 2016, for reasons I won't go into, the author of leftpad chose to unpublish all of his NPM projects. And in doing so, he single-handedly broke the builds of thousands upon thousands of projects, including Node, Babel, and, you guessed it, React. It was so disruptive that NPM actually took an unprecedented step of republishing the package without its permission. Now, most React app developers never deliberately installed this dependency and may not have even known it was there, because they existed at least 4 or 5 levels upstream from them. The incident highlighted the risk and fragility of the large dependency trees that are common in the NPM ecosystem. Now, there's a couple things to keep in mind about this story. First of all, the author of LeftPad wasn't acting maliciously. And secondly, while a lot of things broke, they broke in a clean way with a fatal error on build. So comparatively speaking, it was easy to discover, report, and fix. But any NPM package might also have its own security vulnerabilities, or might even contain malicious code. There are a lot of packages out there that contain malicious code that's scary, actually. And it might be tucked away inside something seemingly useful. And when your application has hundreds or thousands of dependencies 4 steps removed from the dependencies you declare, your potential attack surface increases significantly. So according to the internet, if you use Create React app to start a new React project, you'll get 1,568 dependencies right off the bat, before you extend the world. Now, when people say this, React developers point out that you don't have to use Create React app to build a project, and obviously it includes development dependencies, so I couldn't tell if this was just fun. So to understand better, I looked at a real project directly relevant to Drupal's future. The drupal-admin-ui project is a proof of concept being built by the JavaScript Modernization Initiative for a fully decoupled Drupal admin frontend. It's built on React and uses web services to communicate with Drupal's APIs. As of last week, if I'm not mistaken, it had 1,732 production dependencies. Now, it's also worth noting that 60 or so of these dependencies are different versions of the same packages, which is a feature that Yarn has to deal with dependency conflicts. But that, of course, adds other complexity because then you have to worry about multiple different versions, not just the one. It's possible to do a flat install, but that requires manually resolving every single version conflict, which is obviously a ton of work if that's 60 of them. And then that still leaves 1,600 some other individual packages made by who knows how many different people. So this problem of large dependency trees is a real thing that we're going to have to deal with in the future. Now, there are mitigating factors from a security perspective. Unlike Composer, the popular JavaScript package managers like NPM and Yarn do include built-in functionality to audit all of your dependencies for known security vulnerabilities. I couldn't quite figure out how NPM Audit and Yarn Audit work under the hood. We able to run the commands, but I wasn't able to figure out where the data is coming from or anything. So if you know, I would love it if you would tell me. After this, not during the talk, but afterward. Now, keep in mind, this is only auditing known public vulnerabilities. So it doesn't help you with things that aren't released yet, and it doesn't help with things that aren't included in whatever list is maintained wherever. And I also don't really think that there's any hope of coordinated disclosure windows or whatnot when we're talking about 1,000+ projects. So something we're going to have to figure out is when and how, or if, we'll issue security releases for vulnerabilities in Drupal React app dependencies, and how we'll balance stability and security with the dependency tree that's changing every day. So let's think about some of the lessons we can draw from all this. I think the most important lesson from our experiences is to be careful with external dependencies. They can add a lot of value, but they can also expose you to fragility, instability, and security complications outside your control, especially when you have hundreds or thousands of them. Every piece of software on your site is additional attack surface. The simplest thing you can do is to limit what dependencies you install in the first place. Only add them if you need them, and choose which you want carefully. Be sure to review your dependencies too, because those are also going to become part of your application. Look not only at the functionality, but at the code quality, package, policies, and the release history. Another thing to keep in mind is to keep your dependencies up to date and address deprecations and breaking changes before a lack of security coverage becomes an issue. That said, you should also lock the versions you're using so that they only get updated when you specifically intend it. New versions can introduce breaking changes, and in practice, that might happen not only in major versions, but sometimes also in minors and patch releases. Plus, indiscriminately updating to new releases can also put you at an added risk if a package is compromised by someone malicious. Think about which dependencies are needed in production, and then limit the rest to your development environment. But keep in mind, development dependencies can expose you to security risks too. We had that with PHP in a Drupal security advisory back at the beginning of 2017. So keep them up to date and use a secure development environment like we have. NPM and Composer packages both have the ability to run arbitrary shell commands on your CLI. You can also consider ignoring these scripts unless you're sure about what they do and what you need them. The commands to do that are on the slide here, or you can Google it. Also remember that your dependencies mostly aren't covered by Drupal's security report, so be sure that you're auditing their security. NPM and Yarn both have commands to audit packages for known vulnerabilities. Note that NPM does this automatically on install, but Yarn doesn't. So if you're using Yarn, be sure to add audits to your continuous integration. Composer lacks any features for checking security advisories, but there are a few workarounds you can use. The folks behind Symfony have both an open source database of known advisories and a security checker that will audit your composer.log file for existing known vulnerabilities. The manual checker is free, and then it has an automatic checking service with push notifications as a paid service. There's also a couple of Composer packages that will declare version conflict with insecure versions of other Composer packages, including one Webflow wrote specifically for Drupal security advisories. But remember that these are third-party tools and won't necessarily have a complete list or be up to date. I'm really hoping that the composer community will eventually solve this natively, and also that the recent beta security features on GitHub will sort of push the open source ecosystem generally into more secure practices. Another lesson for the Drupal community specifically is that we need to improve the way we use Composer. Some of the struggles we've had were made worse by the fact that we both use Composer and provide a package tarball for download, or by the fact that we essentially have two package managers right now, Composer and Drupal Zone. The Composer Support in Core initiative is the first step for improving how we use Composer, but it's just the first step. Some initial things we should consider in the future are surfacing information about Composer dependencies in the Drupal UI, and maybe making an official Drupal security advisory package list, like Webflows, that's an official and automatic part of our release build process. Another thing we probably want to do down the road is make modules and themes first-class Composer packages, but only if we can find a way to retain the additional functionality and security that Drupal's package management provides. In closing, the last general lesson I draw is that this is the new normal. Now, of course, package managers themselves aren't a new thing. Pair has been around since most of us could do singing impressions of our dial-up modems, right? But what's changed is that we have modern package managers now, and that web developers expect to be able to use them to build their applications. I don't think we can or should put the genie back in the bottle. We still get a lot of advantage from using third-party dependencies, and if we want to be sustainable as a project, we need to engage with other communities and meet community developers' expectations. So we need to adapt and iterate on our best practices to stay relevant and take advantage of the new normal, but at the same time try to mitigate the risks therein. Before I wrap up, let me circle back to the question that I posed at the beginning of this talk. Based on all this, how long will Drupal 9 be supported? When will Drupal 10 be released? And what's the Drupal release schedule going to look like in the coming years? So we know that site owners vastly prefer long-term support releases. So we want to have a major release cycle where each major is supported for as long as possible. However, we also know that site owners perceive Drupal as unstable if there are major version updates of dependencies in minor releases, even when those updates are allowed by central policy and announcement in advance. So to figure out how exactly we need to do before Drupal 9's release and how long we can support it afterward, we spent a lot of time evaluating the future of our dependencies, including talking to upstream maintainers about their plans. For example, we talked to the CK Editor maintainers about CK Editor 5, and realized that it's too much of a breaking change for us to complete before Drupal 9. So instead, we'll add support for it experimentally during the Drupal 9 cycle in minor releases using the continuous upgrade path, and then make it the requirement for Drupal 10. We've also learned that Drupal, during this cycle, that having external PHP dependencies in general adds pressure to only support the latest versions of PHP. But at the same time, dropping support for PHP 5 was a lot of work for us, and I imagine for site owners too. So we'd like to minimize how often we have to do that mid-major release in the future. If we time our releases right and set each major release's requirement high enough, we should be able to provide at least 3 years of support for each major version. Unfortunately, 3 years is a far shorter period than Drupal site owners are used to these days. Drupal 6 was supported for 8 years. Drupal 7 has been supported for 8 years already, and they'll get 2.5 more. And Drupal 8 is going to make it to 6 years. So we're looking at other ways to stretch the length of our major version support, like doing our major releases soon after Symfony's majors, or having a gradual process for dropping support for old PHP versions. All in all, we think we should be able to support Drupal 9 until at least the end of 2023 for a 3.5-year lifetime. Still shorter than I would have liked, but based on the constraints around this, it's probably where we're headed. The one risk we haven't come up with a strategy for yet is PHP 8. Who's heard about PHP 8? Yeah, 4 people, cool. It's been announced that PHP 7.4 is the last release of PHP 7. So PHP 8 is next after that. And so far, the PHP maintainers don't want to extend its security coverage the way that they did for 5.6. So right now, it's looking like PHP 7.4 might only have 3 years of security coverage and have its support end as early as November 2022. I'm hoping that the PHP community can convince the maintainers to stretch this out by another year and end in the end of 2023, because that would give a much smoother transition for not just for Drupal, but for the entire ecosystem. But either way, my best guess right now is that we'll want to release Drupal 10 sometime in 2022. You heard it here first. No guarantees about that date. There's a lot of things that could change that prediction. But if we're successful with the continuous upgrade path, it actually shouldn't matter as much what the exact release date is. And I can promise you that we'll announce whatever release date at least a year in advance. Thanks for listening and for being my guinea pigs for the first version of this talk. Mutsumes. I didn't include the link to the survey that I was supposed to hear because it doesn't seem to work. But I know that event organizers in general like feedback about their events, so if and when there is a working survey, please let the event organizers know what you thought about the session and about the event in general. If you want to help out with Drupal 9 preparation or composer support or educating me about React, you can stay right in this room to sprint or join us with us anytime this week. There's a group photo, you can go out and come back if you want to sprint here. I'm not going to do the photo because I'm lanyard, but I'll be sprinting here. You can also join the D9 readiness channel in Drupal Slack. There are meetings every other Monday at 1800 UTC. So yeah, that's all I've got, and I'm told that I'm supposed to go over and look at the QA now, so I'm going to do that. We have a minute and 15 seconds left, which means I talk too fast. What is the process for removing a dependency? Is the first question. Maybe we could use some cleanup now. Yes, absolutely. So the process for removing dependency is that we try as much as possible, obviously we need to couple everything from it. In the past, a lot of the time, we've moved support for things to contrib. I'm not quite sure how, that's how we managed to get the PHP module out of core, for example. They were the diehards who were like, you're taking PHP module out of my cold, dead hands. So that's how we eventually got rid of it from core. Of course, no one actually maintains it. Sorry, it's Andre here. Someone might maintain it, maybe. But yeah, this will be the first time I think that we've actually tried to remove a dependency that is tightly coupled to what Drupal does. We've removed dependencies before. Basically, the process is someone opens an issue, says, we should remove this dependency for reasons, and then we look at how we can work on it in the current release without breaking backwards compatibility, find something to replace its functionality with, and then switch over to that. And yes, the end of life for Drupal 8 and the release of Drupal 9 is an opportunity to do that. So will the end of life for Drupal 9 be if we don't manage to remove some of them. Okay. Second question. The security team has been amazing since it exists. Does the security team have people with JS know-how to deal with 1.7K dependencies? The answer is probably no. I think that there are members of the Drupal security team who have had to deal with providing security for their own company's applications that involve large NPM dependency trees. That knowledge exists on the team. And there are some members of the security team who write more JavaScript than I do at least. But there's one provisional security team member I know of who's primarily a JavaScript developer. I can't think of anyone else. So if you know things about JavaScript and you know things about security, there's a process for applying to become a security team member that you might enjoy. Yeah, it'll be interesting. This is one of the things that we're going to also have to figure out with adopting React is how, do we even try? Is it covered by Drupal security policies at all, and how does that affect site owner expectations? Should I wrap up? One more question? Yeah, okay, so let's see. The third question is, contrib modules assume a lot about upstream dependencies of core. If they would make explicit requirements, would that make help, or would that make security fixing more complex? I think that explicit requirements would be excellent, great, important. I think this is part of what we need to do in the future. If we have a world where Drupal modules are first-class packages, they can use, like composer.json and package, they can use the package manifest files for the respective package manager to actually list their own dependencies, and that will make it easier for us to, figure out it'll make us easier to support sites in figuring out whether the dependencies are up to date and keeping the sites secure. The security team, again, still won't be providing security coverage for those upstream dependencies. They're only responsible for our code. But yes, I think that's important, and it's a great idea. And hopefully it's something that we can develop in Drupal 9 and make therefore a part of the way things work in Drupal 10. I think that's the end. Good. Or should I ask the last question? I can't understand your hand gestures. You're smiling and nodding a lot.
Ask it.
Okay, so if Drupal 8.9 will be around for 18 months without the hassle of a minor update, might there be a risk that many smaller sites see that as a really attractive option? I don't think it's a risk. I mean, it is an attractive option. It's just that, for 18 months, if you wait until the end of the 18 months and then don't get the next security update, that's your choice. It's the same as right now. If you stay on Drupal 8.5, which is security coverage just ended, if you're running Drupal 8.5 right now, you've made a choice that you haven't been able to invest the time in updating yet, and you're willing to take the risk that you might have to do it all at once in a security update if one comes out next week when we have our next program there. Cool. All right. Thank you very much. If you have any more questions or comments or feedback, feel free to type me down. And I think it's time to let everyone out of the human room and go take a group photo. Enjoy.